So I'm very happy to be here to share with you some of our recent research on enhancing AI-assisted decision-making. So as we all know, the AI technology has made remarkable progress in the past decade. Today, AI has been widely applied to many different areas in our daily life, from finance to healthcare to criminal justice. And this rapid development of AI has also fundamentally changed how decisions are made today. So in the past, given a decision-making task, usually it's a human who will process this task and deliberate about different possible options and make final decisions. But today, AI models have been trained to uncover hidden insights from the big data. So now, given these same decision-making tasks, those decision aids that are powered by AI models can analyze the task and come up with some decision recommendations, which will later be presented to human decision makers to assist them in their decision-making. So, of course, this essentially transformed the decision-making from the task of humans alone to a task that is jointly completed by human decision makers and AI model. And the hope here is that because human and AI each have their respective strengths and weakness, through collaborating with each other, they can complement each other's strengths and weakness, and therefore, as a team, they can achieve a level of decision-making performance that outperform either human alone or AI alone. But in reality, this kind of human-AI complementarity is rarely observed. And naturally, we will wonder why this is the case and what we can do in order to improve the AI-assisted decision-making performance. So I will argue that in order to improve the performance of AI-assisted decision-making, there are two essential steps for us to take. First, we really need to obtain more empirical understandings of how exactly do human decision makers engage with AI-based decision aids. So this could mean how will human decision makers trust and rely on the recommendations provided by AI, and this could also mean how human will factor AI models' decision recommendation into their final decision. Now, with this empirical understanding of humans' interaction with or humans' engagement with AI-based decision aids, the next step is really to leverage this understanding and improve the designs of AI-based decision aids to account for humans' engagement behavior. And in today's talk, what I'm going to do is that I will share with you a couple of projects that is carried out in my group along these two directions and showcase how we may leverage our understandings of humans' engagement with AI to improve AI-assisted decision-making. Okay, so now let's start with this first step, obtaining more empirical understandings of humans' engagement with AI. So in the past few years, my group has carried out a number of empirical research projects to look into how exactly do humans engage with AI in this joint decision-making process. And we have identified a number of interesting lessons through this process. The first lesson that we learned is that in collaboration with AI-based decision aids, humans' trust and reliance on AI is often shaped by various performance indicators of the AI model, especially AI's performance that humans observed in the field by themselves. Now, secondly, in addition to AI's performance, we also find that humans' confidence in their own independent judgment on different decision-making cases will influence how much they are willing to listen to AI's suggestions. So holding everything else equal, humans are more likely to be receptive to AI's decision recommendation when their own decision confidence is relatively low. Now, in reality, there are actually many cases that humans will not observe any AI model's performance. So in those cases, how would humans decide how much to trust or rely on AI? And the third lesson that we find here is that when AI performance information is absent, humans have this tendency that they will make use of the level of agreement between AI model's decision recommendation and their own independent judgment on cases that they feel confident about to gauge the trustworthiness of the AI model. So we find out this lesson through a human subject experiment. So now let me actually tell you a bit more about this human subject experiment. So in this experiment, what we ask the human subjects to do is to complete this speed dating prediction tasks. So essentially, we will give our subjects a speed dating profile, like what I'm showing to you here on the screen. So this profile contains information like the demographic background of the participants in the speed dating event, as well as the demographic background of the date. And we will show them some information in terms of what kind of things that these participants value in their romantic partner and what's their impression of their date in the speed dating event. So after reviewing all this information, what we ask the subjects to do is to first come up with their own independent judgment in terms of whether they think the participant in the speed dating event would be willing to see the date again in the future. And after they make their independent judgment, we're going to show to them an AI model's prediction as the decision recommendation. And finally, the subjects need to submit their final decision, and they are free to decide whether they want to follow AI's suggestions or not. Okay, so now in order to enable our later experimental design, as the first step, we carried out a pilot study just to get a sense of, for different speed dating outcome prediction tasks, usually what kind of decisions that people may come up with and how confident they are about their decision. So what we did is we asked our human subjects to complete a large set of speed dating outcome prediction tasks on their own, and on each of the tasks, we're going to show that we're going to ask them to provide both their binary decision and also we ask them to indicate how confident they are in their decision. So with this information that we collected from our subjects, we are able to categorize different decision-making tasks into several categories or groups. For example, the first group of instances are those decision-making tasks where the overwhelming majority of the human subjects, meaning more than 80% of the human subjects, when they make decisions on those cases, they tend to make decisions, the decision is correct, and they also tend to make those decisions with very high confidence. And the second categories of task instances are those cases that when people make decisions on them independently, they make wrong decisions, but they also make wrong decisions with very high confidence. And you can imagine the third and fourth categories of instances are the ones that the overwhelming majority of the human subjects, when they make decisions on those cases, they are either making correct decision or wrong decision, but when they make those decisions, their confidence is relatively low. Okay? So now with these 4 different types of instances being identified, I'm ready to tell you about our formal experimental design. So in the formal experiment, what we asked subjects to do is to complete a same sequence of 40 decision-making tasks with the help from an AI model. And throughout this experiment, we never tell our human participants how good the AI model performs. And these 40 tasks are divided into 2 phases, with each phase containing 20 tasks. Now, for the first 20 tasks in phase 1, we made sure that all those 20 tasks in phase 1 are selected from the first 2 categories of task instances as we identified in the pilot study. Meaning that when human subjects make independent decisions on those cases, they tend to have high confidence in their own independent judgment. And then what we did is we created 3 experimental treatments by varying how frequently AI models' decision recommendation agree with humans' majority judgment on the 20 tasks in phase 1. So this level of agreement can be as low as 40%, meaning that the AI's suggestion is only the same as humans' in majority judgment on 40% of the phase 1 tasks, or it can be as high as 100%, meaning the AI's suggestions is completely agreeing with humans' independent judgment on all tasks in phase 1. So if you think about it, for our subjects, in phase 1, they essentially see exactly the same 20 decision-making tasks, but depending on the treatment they get assigned to, they receive different recommendation from the AI model in phase 1, and they experienced a different level of agreement between AI and themselves on cases that they feel confident about. And another caveat that I want to mention here is that even though in this experiment we never tell our subjects how good or how bad the AI model performs, to make sure that AI model's actual performance is not going to be a confounding variable of our experiment, we also made sure that in phase 1, across the 3 treatment, the AI model's actual accuracy is exactly the same. And the way that we do this is, in this 3 treatment, for this high agreement treatment, we have no choice but to set AI model's decision recommendation to be the same as humans' majority judgment on each of the tasks. So this means that whenever human is correct, AI is also correct. When human is wrong, AI also is wrong. But as we move from high agreement treatment to low agreement treatment, what we did is that every time when we flip AI's recommendation on a task that humans' majority judgment is correct, we also flip AI's decision recommendation on another task where humans' majority judgment is wrong. So we are able to preserve the AI's accuracy across the 3 treatment, but create different level of agreement. And one note that I want to make here is that if you look at this low agreement AI model, it actually is the model that complements humans' expertise the most, because it's most likely to be correct in those cases that humans' own independent judgment is wrong. So I'll come back to this point a little bit later when we discuss about the result of our experiment. Okay, so this is phase 1. Now we move into phase 2. So the goal of phase 2 is try to say, after our subjects experienced a different level of agreement between AI and themselves, will they actually trust or rely on AI in a different degree, when they are, make decisions later on. And in order to maximize this possible effect, for the 20 tasks in phase 2, we select them all from the 3rd and 4th categories of instances in our pilot study. So when humans make independent judgment on phase 2 tasks, they tend to make their independent judgment with low confidence. And this time in phase 2, we made sure that across the 3 treatment, the subjects not only see exactly the same 20 decision-making tasks, but they also received the same recommendation from the AI model.
Yep. Clarification. To make sure I follow, for example, in the low agreement case, this is not an actual algorithm then that's like you are assigning it the recommendations?
Yeah, so we are simulating how the AI will perform. We are assigning AI model a different prediction. Although in reality, if we want to train an AI model, we could train an AI model to behave like this on selected tasks as well.
Okay.
Yeah. Okay. Cool. Okay, so in order to quantify our subjects' trust and reliance on the AI model, what we did is that we asked the subjects to report their perception of the AI model, both at the middle of the experiment and at the end of the entire experiment. And we also looked into, in phase 2, when the AI model provides exactly the same decision recommendation across the 3 treatment, how frequently our human subjects' final decision is the same as AI model's decision recommendation, especially if humans' initial judgment is different from AI's decision recommendation. So these 2 metrics, agreement and switch fractions, are the metrics for us to quantify people's reliance on AI. And you can imagine the higher the value, the more people relied on AI. Okay, so now let me share with you what we find in this experiment. So as you can see from the figure here, what we see is that as we increase the level of agreement between AI model and humans' independent judgment in phase 1, in cases that people feel confident about, our human subjects generally report that they see the AI model as more accurate, more reliable, more understandable, and they trust the AI model more. And in the end of the day, they also relied on the AI model's decision recommendation more in phase 2. But again, recall across the 3 treatments, our AI model actually provide exactly the same decision recommendation to people in phase 2. So in this sense, what we observe here seems to suggest that when people do not have any performance information about an AI, they have this tendency to make use of the level of agreement between AI and their own independent judgment on cases that they feel confident about as a heuristic to gauge the trustworthiness of the AI model. And if you think about it, this kind of heuristic is highly related to one type of human cognitive bias, which is confirmation bias, right? So essentially, whoever agree with me is great. I'm going to follow their recommendation. Whoever disagree with me, it will be ignored. So in this sense, our findings here seems to suggest that humans may even exhibit a degree of confirmation bias towards AI model who provide decision recommendations to them. And you can potentially imagine this kind of possible confirmation bias will bring up some risks. For example, if we look back into how our human subjects rely on AI models' decision recommendation in phase 2 one more time, but this time we separate the case where AI's decision recommendation is correct versus the case that AI's decision recommendation is wrong, you see that the general pattern across the 3 treatments is the same in both scenarios. So this really suggests that humans may overtrust an AI model's wrong decision recommendation just because the AI tends to agree with themselves, and humans may undertrust an AI model's decision recommendation just because AI tends to disagree with themselves. And in fact, if we look into the final decision-making accuracy across the 3 treatments, you can see that no matter whether we are looking into the accuracy in phase 1 or phase 2 or 2 phases combined, we actually see very limited difference across the final human decision-making accuracy across the 3 treatments. And this is rather disappointing, right? Because as we mentioned before, the AI model used in this low agreement treatment is actually an AI model that's highly complementary to humans' own expertise. And this seems to suggest that because humans have this tendency to undertrust an AI model that is highly complementary to their own expertise, they may actually miss the opportunity to fully release the potential of human AI complementarity when the AI model tries to complement their expertise. And finally, in some of our recent research, we also noticed that this confirmation bias may actually reflect a serious vulnerability in human AI collaboration. This is because the adversarial parties could understanding humans have this confirmation bias towards AI, they could choose to selectively attack the AI model on those cases that they feel humans will be confident about. And doing this will help them to destroy humans' trust in AI in the most fast way. And in fact, the adversarial parties could even use some computational models like a hidden Markov model to categorize how their attacks to these AI models will influence people's trust and reliance on the AI model. And eventually, using the insights that they obtained from these computational models, they may be able to develop some strategy to strategically deploy the attacks to AI models such that they will maximize the reduction of human AI joint team performance in decision making while minimizing the cost of attack. So this really suggests that it is urgent for us to think about how can we leverage our understandings of humans' engagement behavior with AI to really combat against the adversarial parties and secure the human AI collaboration. Okay, so that's all for the first part that I want to show, understanding humans' engagement behavior with AI. Now let me move on to the second part. Once we have this understanding, how can we design interventions to improve the human AI team performance in decision making? So ideally, what we really want to achieve is that we want the human decision makers to collaboratively combine their wisdom reflected in their own independent judgment with AI models' decision recommendation. But what we see in the previous project basically says that humans are not doing that, right? Humans are leverage their independent judgment in a rather heuristic way. They are not really utilize their strengths and avoid their weakness in their independent judgment. So now the question is, how can we help humans utilize their strengths and avoid their weakness in their independent judgment? So we looked into this in a recent Kai paper, and we actually came up with a fairly straightforward thought. We think that in order to help humans utilize their strengths and avoid their weakness, we first need to let humans know where their strengths and weaknesses are, especially in comparison to AI. So this means that it will be super great if on each individual decision-making task, we can estimate how likely humans' decision is going to be correct on that case, and how likely AI's decision recommendation is going to be correct on that case. Because if we are able to come up with this kind of correctness likelihood estimation, then maybe we can guide the human decision makers to follow AI when AI is more likely to be correct, and we can guide humans to follow themselves when they themselves are more likely to be correct. So this vision is really nice, but in order to realize this vision, we have a couple of practical challenges to address. The first practical challenge is that how can we actually estimate the correctness likelihood of both human and AI? And AI side things might be slightly easier because we can potentially just use AI's calibrated confidence score as an indication for this correctness likelihood. But what about humans, right? How can we estimate humans' correctness likelihood on different decision-making tasks in the real time? So that is our challenge number one. Now, challenge number two is even if we are able to obtain this correctness likelihood estimation for both humans and AI, what should we do to communicate this information back to human decision makers so that we can nudge them into taking more rational, quote unquote, rational actions by either follow AI or follow themselves? That's our challenge number two. So in the next few minutes, I'm going to expand a little bit on how we address these two challenges. Starting from the first one, how can we estimate humans' correctness likelihood on different decision-making tasks for which we may not even know the ground truth answer? So this sounds to be a relatively complicated task, right? So if we don't really know the ground truth answer for a decision-making task, how can we even know whether human is going to be correct or not on that task? So here we are making an important assumption. We are assuming that if a person's decision on a task that is similar to the current task is correct, then this person's decision on the current task is more likely to be correct. So if you agree with this assumption, then potentially one way we can adopt to estimate humans' correctness likelihood on a particular decision-making task that we don't really know the ground truth answer is that we can just look into some other tasks that are similar to this current task, and we check how frequently humans' final decision is correct on those other tasks. And for those other tasks, we need to know the ground truth answer. And one way for us to get those other tasks could be coming from the AI model's training data set. So with this idea in mind, we actually developed a four-step workflow to estimate humans' correctness likelihood on a decision-making task. So what we did is that we start by having the human decision makers complete a small set of decision-making tasks on their own. And using the data we collected from the human decision maker, we are able to learn a decision tree to roughly categorize how this decision maker makes their own independent decision. And then we extract rules from this decision tree and present the rules back to the human decision maker. So if the human decision maker thinks some of the rules in this set is not accurately reflect their own decision rationale, they can also modify those rules. And in the end of the day, what we did is that using this user-modified set of decision rules, we are able to predict what kind of decision this decision maker may make on each of the training task instances of the AI model's training data set, and we can determine whether those predicted decisions are correct or not. So in the runtime, if we want to estimate the decision maker's correctness likelihood on a new task instance, what we will do is we will fetch a number of training task instances that are similar to this new task instance, and we will try to check how frequently humans' predicted decisions on those similar training task instance is correct. And that frequency will be used as our correctness likelihood estimation for the human decision maker. Okay, so that helps us to solve the first challenge, how to estimate humans' correctness likelihood on different decision-making tasks. But we still have another major challenge ahead of us, which is how can we communicate this information back to the human decision maker. So perhaps one of the most intuitive thought is that let's just tell people directly. That's actually our first intervention, which is direct display, right? So on this interface, you see we tell human decision maker, here is our estimate of how likely you are going to be correct on this instance. Here is our estimation of how likely AI is going to be correct on this instance. And this is just AI's calibrated confidence score. And we present both type of information to human decision maker and ask them to do whatever they want, right? So they can process this information and react in whatever way that they prefer. So this serves as our first intervention, direct display. But after we came up with this solution, we thought that maybe this is too blunt, right? This is too straightforward. So maybe we should try to communicate this information in a slightly more subtle and indirect way. And the question then is how can we communicate this information in a slightly more subtle way? And we thought that this subtle communication or indirect communication of correctness likelihood is actually possible. And one of the important bases for this indirect communication to be possible is that actually some of the previous research have already found out that when you use certain interfaces in the AI-assisted decision-making process, those interfaces will nudge humans to decrease their reliance on AI. But the drawback of those interfaces is that they will decrease humans' reliance on AI, both when AI is correct and when AI is wrong. And that is not desirable, right? Because when AI's recommendation is correct, we don't really want humans to decrease their reliance on AI. But even though this is, limited, this is a type of limited interface, that actually provides opportunities for us to communicate the correctness estimation of both human and AI in an indirect way, because this means that we may be able to design some adaptive interface such that, when on the decision-making task, we find human is more likely to be correct than AI, those are the perfect moments that we want humans to decrease their reliance on AI, and those are the perfect moment for us to use those interfaces that are known to decrease humans' reliance on AI. Okay, so with this idea in mind, we came up with two additional interventions. And this first intervention, this is now the second intervention, is what we call adaptive workflow. And the key idea here is that we are trying to adaptively decide when to present AI models' decision recommendation to human decision maker. And as you can see here, so what really happened is on the decision-making task, if we find human is more likely if we find AI is more likely to be correct than human, we're going to show to human decision makers the AI's decision recommendation upfront. Otherwise, we're going to ask the humans to first make their own independent judgment and then show to them AI models' decision recommendation. And this is precisely because some of the previous research have found that after humans register their own independent judgment, even after they see the AI models' decision recommendation, they're less likely to switch to AI models' decision recommendation. Okay, so now the third intervention that we came up with is what we call adaptive recommendation. And in this intervention, we're essentially adaptively change whether to provide AI models recommended decision to human at all. So in this case, if on the decision-making task, the AI's correctness likelihood is higher than humans' correctness likelihood, we're going to show both the AI's explanation to its decision and the recommended decision to human. Otherwise, we're going to only show the AI's explanation without showing to them the precise recommended decision. And this is, again, because some of the previous research have found when people only see AI's explanation and do not really see the recommended decision, they are less likely to eventually agree with with AI's recommended decision. Okay, so now I've introduced the three different types of interventions that we came up with, and what we did is we tried to carry out a human subject experiment to test whether these interventions can help us improve the AI-assisted decision-making performance or not. And as you can see here on this figure, so compared to a baseline condition, so this is like the human's own performance. The dashed line is AI's own performance. And this baseline condition we're considering now is a default scenario that we always show to the human decision makers, both the AI model's recommended decision and its confidence. And what we see here is that when we provide the three types of decision interventions to our human decision makers. Our human decision makers generally have a marginal or significant increase in their final decision-making accuracy. And if we look closer into the data, what we find is that this increase in decision-making accuracy is mostly caused by the decrease of humans' over-reliance on AI when AI makes wrong decision recommendation. And when AI makes correct decision recommendation, we find that our interventions do not significantly affect people's trust and reliance on AI. Okay. Okay. So up until now, the way that we try to adjust the designs of AI-based decision aids is pretty much to, adaptively change how AI's recommendation is presented to human decision makers. We try to influence how human behaves, but we don't really change anything about the AI model. We are assuming the AI model is fixed and is given, right? But alternative way that you can think of to change to improve the designs of AI-based decision aids is that we can really retrain the AI model to anticipate humans' engagement behavior and accommodate to humans' engagement behavior. So this really requires us to move away from training behavior oblivious AI model, in which case we are really trying to find the optimal model parameters that optimize for AI's own decision-making performance. But what we really want is to train some behavior-aware AI models. So these behavior-aware AI models will explicitly account for how humans will react to AI models' decision recommendation into their training objectives, so that they will directly optimize for the human-AI team performance in decision-making. So as an example, we have a recent study trying to look into a particular human behavior model that is inspired by our empirical understandings of humans' engagement with AI. So this model essentially says that, the human decision maker will go with their own independent judgment when their confidence in their own judgment is higher than the threshold. Otherwise, they will go with AI model's decision recommendation. And we assume that this confidence threshold is sampled from an underlying distribution. And it turns out that under this human behavior model, the problem of optimizing for the human AI team performance in decision making is effectively the same as trying to solve a weighted loss optimization problem. And the weight assigned to each of the training task instance is actually the optimal weight assigned to each of the training task instance is actually 1 minus the CDF function value for humans' own decision confidence on the training instance. So essentially, when humans are more confident about a training task instance, that training task instance gets a lower weight in the training process. And through both the human subject study and simulation, we actually find that when humans are collaborating with a behavior-aware AI model, they are able to achieve a significantly higher level of final decision-making accuracy than in the case when they are collaborating with behavior-oblivious AI model. Okay, so now so far, when we are talking about enhancing AI-assisted decision-making, we are really just thinking about the scenario that AI models is trying to help an individual decision-maker in decision-making. But in reality, a lot of times the decisions are not made by an individual. It's made by a group of people. So this really means we need to think about how to enhance AI-assisted group decision-making. And I would argue that the recipe is still the same, right? So in order to enhance AI-assisted group decision-making, we probably want to start with obtaining more understanding of how a group of decision makers will engage with AI-based decision aids. And then with that understanding, we can try to design AI-based decision aids to account for groups' engagement behavior. So in the next few 10 minutes or so, I'm going to share with you some initial explorations in terms of how we can actually understand groups' engagement with AI and how can we account for groups' engagement with AI in the designs of AI-based decision aids. So let's start from the empirical understanding. So in this case, one of the first question we want to ask is, compared to an individual decision makers, how will a group of decision makers engage with AI in a way that is, do they engage with AI in a similar way or a different way? So to understand this, we ran human subject studies to have decision makers make recidivism prediction, right? So essentially they are looking at the profiles of criminal defendants, and we ask them to decide whether the criminal defendant may be reoffend in the future. And so we create two experimental treatments. In the first treatment, we ask the decision makers to review the defendant profile and make their own independent judgment with the help with AI model. And in the second treatment, we organize the decision makers into groups of 3 people. And these 3 people actually need to look at the profile of the criminal defendant and discuss with each other. And they, in the end of the day, they need to come up with a consensus decision. Again, this is with the help of an AI model. So AI will provide some decision recommendation to them. So we actually looked into multiple different aspects in terms of how individual and groups engage with AI similarly or differently. So we looked into their final decision-making accuracy, their reliance on AI, fairness, confidence, accountability, their understanding of AI, and so on and so forth. But for today, I'm going to only focus on highlighting one of the most striking results to us, which is in terms of groups' reliance on AI. So what we find is that compared to individual decision makers, a group of decision makers actually relied on AI's decision recommendation even more, both on cases when AI is correct and on cases where AI is wrong. So this effectively leads to a lower degree of under-reliance for groups, but a higher degree of over-reliance for groups. And we wonder why this is the case, right? So we looked into the chat logs for groups and tried to find out why this is the case. And we find out a couple of very interesting scenarios or common things in the chat logs. One possible scenario is that within the group, someone will just make the case for their own judgment by saying that, look, AI agree with me. So that must be saying something about my judgment being superior. So they try to make use of that to persuade other members in the group to vote together with them. So this is one of the frequently observed patterns in the group discussion process. Another frequently observed patterns in the group discussion is that in some cases, a group cannot reach a consensus. And then somebody in the group will jump out and say, well, since we can't really reach a consensus, let's just use AI models recommendation as the tiebreaker. So that, again, you can imagine, significantly increased the chance for people to use AI models decision recommendation as their final decision. So this result really hints us that in order to improve AI-assisted group decision-making performance, we really need to think about how to help groups to critically reflect on the trustworthiness of AI models decision recommendation. They really need to engage in more sort of critical deliberation in this process. And if we look into the traditional management science literature, we'll find that one frequently used approach to encourage critical deliberation is to introduce a devil's advocate in this group discussion process. But the traditional type of devil's advocate may suffer from a couple of limitations. For example, this traditional devil's advocate approach, they will assign a particular person in the group as the devil's advocate and ask that person to, come up with opposing views. But that person may not actually agree with the opposing views that they get assigned, and as a result, they can't really come up with very convincing arguments to help this group to generate more deep thinking. So that's one of the limitations. And another limitation is that the devil's advocate in the group, when they get assigned this role, they sometimes suffer from psychological safety issues because they are trying to sort of be the outliers of the group, and they're trying to advocate against other people's opinion, and therefore they sometimes feel that they get isolated in this process. So in order to address these two limitations, we start to think, maybe we can use a large language model to power this devil's advocate. So because if we use language model to power this devil's advocate, we potentially could generate more genuine opposing views, because in a sense, language model, once you prompt them to do certain things, they can come up with the best or strongest argument that they can think of. And since language model is not a human, at least we think they are not a human at the moment, they will not suffer from any psychological harms that humans may suffer from. So, with this idea, we start to explore, whether we can actually introduce language model-powered devil's advocate in AI-assisted group decision-making process to improve the group decision-making performance. And we thought about two dimensions that we can vary in the designs of the language model-powered devil's advocate. The first dimension is who this devil's advocate should get object to. So traditionally speaking, the devil's advocate is supposed to oppose the majority view within the group. And that's one option that we considered. But since our previous empirical study have revealed that the groups have the tendency to overly rely on AI, we also considered another option, that is having the language model-powered devil's advocate to specifically advocate against AI models' decision recommendation. So this is the first the dimension that we varied. And another dimension that we varied is the interactivity of the devil's advocate. So the simplest design is a static devil's advocate. So we only have the devil's advocate to generate some thought-provoking, critical initial questions and add then at the top of the group discussion to encourage the groups engage in this kind of critical thinking. But we also thought about potentially more interesting language model-powered devil's advocate could be this dynamic devil's advocate that will actively participate in the group discussion and respond to other members' argument. And that's our second option along the interactivity dimension. So again, we tried out this combination of 2x2, so it gives us 4 different possible design. We tried out this 4 different possible design using a human subject experiment, and what we find is that when the devil's advocate is actively participating in the group discussion and it's actively arguing against AI models' decision recommendation, they can help a group of decision makers to achieve a level of decision-making accuracy that is higher than in the case when there is no devil's advocate involved. And we also find that having the language model to actively respond to group members' argument actually helps the groups to significantly decrease their over-reliance on AI's recommendation. And just to give a sense of what exactly this devil's advocate is doing in this entire group discussion process, we again looked into the chat log and find a couple of very interesting emerging behaviors of this language model-powered devil's advocate. First, what we find is that even though we have never prompted a language model to do so, we find there are cases that this language model-powered devil's advocate will actively encourage certain members in the group to express their opinions. They want to ensure that everyone's voice are being heard, even though this is never explicitly included in our prompt to the language model. And there are also cases that language model-powered devil's advocate will recognize that the group of decision makers are making their judgment based on wrong information. And they will pick up those moments and tell the group of decision makers that pay attention, you are actually making your argument based on wrong information about this defendant. You should really pay attention to what's the actual information presented in this defendant's profile. And there are also many times the language model powered devil's advocate tries to encourage holistic evaluation of the defendant's case. So you can see in this case, the group is actually mostly focusing on one particular feature of the defendant, which is the defendant does not have a prior criminal history. And language model powered devil's advocate will capture this point and try to make sure that they are also paying attention to other features of this defendant that may suggest opposite decisions. And finally, there are cases that the language model will recognize that the entire discussion is based on certain assumptions. And these assumptions may not actually showing up anywhere in this decision-making profile. And they will encourage the group to think about whether their assumption is valid or not. Okay? Yeah.
Thank you for this talk. I'm just wondering, is the fact that the dynamic adversarial AI, is this the best because it's just the AI system itself is going to be better when you put it in this environment where it's like being pitted against another AI, and so sort of like the end result of this like line of reasoning is just the most high quality line of reasoning, or is it something about like the interaction between the people seeing this like adversarial interaction that's helping the group come to a better decision?
So let me try to see whether I understand your question. So you're asking whether the benefit is really coming from their two AI, or one is AI provides decision recommendation, another is AI that is the devil's advocate, or is it because the humans see more information?
I guess it's like if you were to just design an AI system that made the best predictions about your decision task, would the dynamic AI be the best at making predictions aside from like the dynamics of kind of how the group perceives
Yeah, so I guess part of it is the AI's decision. Well, I guess in this particular case, the AI model's performance is probably not so great. You're correct. So the AI model's performance is probably on par with humans' performance. So in this sense, having the devil's advocate to really attacking the AI's suggestions and having people to critically reflect on AI's decision recommendation is very helpful. But you're right in the sense that I don't know whether this result will generalize if in another setting the AI model's performance is super great. Right, like if AI model's performance is super great and the devil's advocate is trying to actively prompt people to think AI is wrong, then maybe it's going to be the case that it's not helped the group achieve a higher level of decision-making accuracy. And in that sense, I think we need to better think about how to design the devil's advocate to really just jump in those cases that they are highly confident that AI is going to make the wrong recommendation. Okay. Yes.
Powered by a large language model?
Yes, we directly told them that there is a devil's advocate in their group, and this devil's advocate is powered by a language model. Yes.
Yeah. What were some examples of like the cases that you were using to determine like the answers were correct or incorrect? Like, were they all like about criminal cases? And in that case, like, what is considered the correct?
Right. So this experiment is done all with the recidivism prediction task. So the data set actually provides the ground truth in terms of for each of the criminal defendants whether within 2 years they reoffend or not. So we are asking the participants in our experiment to predict whether this person will reoffend in 2 years. So in that sense, the data set actually gave us the ground truth answer.
So you already know if the defendant had reoffended, right?
Right, because this is used as a historical data set. But in reality, we won't know. But in a sense, in reality, we would also be able to check whether the decision that the group of decision makers made are correct or not in the future. Yes.
It seems to me that the LLM is playing the role of a facilitator while you are programming it to play the role of a devil's advocate. So I'm wondering if that is because it is something that you already programmed in your original design, or is it something that is doing because somehow it just realized that as a devil's advocate, one of the strategies it can win an argument is to adopt the role of facilitator in its arguments, because you tend to be on the side of where most people don't agree, and you have to play a more facilitator kind of role in order to get people to listen to you.
Yeah, so that's a really great question, and we don't really know the answer. So the way that we prompt the language model in this study is we just, in the system prompt, we say that, there are a group of people discussing about this recidivism case, and you are going to join this group as a devil's advocate, and we ask you to exercise a Socratical method to generate thought-provoking questions, encouraging the entire group to engage in deliberation more closely. And somehow we observed this behavior that the language model actually, in many cases, tries to make sure everyone is contributing equally and tries to make sure everyone is looking at all the possible features of the task. And we don't really know why that happens. And I guess a very interesting future work along this line is really to specifically engineer the language model in a way that separates these roles, right? They separate them into the role of just act as a facilitator or act as a coordinator, and in other cases, just act as a role of throwing out opposing views and see how would the different roles actually interact with each other, or which role is most helpful in encouraging the group decision-making accuracy. Yeah. That's actually the end of my presentation. I hope I have convinced you that it's important for us to understand humans' engagement with AI, because this understanding could both help us to design adaptive AI that will promote more appropriate engagement from the human side, but also we can potentially, retrain the AI model to tailor to humans' engagement behavior. Okay, thank you very much.